So we're going to quickly take a look at the x and y intercepts of any graph. Definition of the x-intercept, we know it's the point where the graph either crosses or just touches the x-axis. So I have three different graphs here, so I'm just going to highlight the x-intercepts on each of the graph. So here on this one, we have kind of a U-looking thing, and I can see that it touches the x-axis right there. And recall the x-axis is down here. So on this graph here, I can see that we have the x-axis, and I'm asking myself, where does this graph touch the x-axis? Well, it touches right there. That's at the point 3, 0. Just as an example, this graph right here, a graph can have many x-intercepts. So here, this one actually has a ton of them. I'm just going to highlight them all. We don't need to worry about the numbers, but it touches the x-axis there, 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 and there. Now, just like it can have many of them, I could draw a graph that never crosses the x-axis. So like this one here. This graph never touches the x-axis, so it doesn't have any x-intercepts. Now, what I want you to notice really quickly is that all the x-intercepts, no matter which ones we look at, this one here is at 0, 0, 3, 0, or even these weird numbers like 2 pi, 0, pi, 0, 0, 0. The most important thing is that we know that the x-intercept always is in the form x, 0, meaning the y value is always 0. Now for the y-intercept, but the y-intercept is either where it touches or where it crosses the y-axis. So again, we know the y-axis is the vertical axis. So I've just labeled the vertical axis. I'm going to have a few graphs here. This one's actually duplicated. So I have a few graphs here. So if I look at this one, I can see that this graph touches the y-axis right there. This graph over here, if I look at this line here, where does this line touch this y-axis? Well, I can clearly tell it is right there. If I add one more example just so we can see it, let's go back and look at kind of that curvy one here. Let's put in this one here. So this graph here, the one that I'm just entering into the picture, where does this graph touch the y-axis? So again, I can see that this graph goes all over the place. Where does it touch the y-axis? Well, it touches the y-axis right there. So what's really important here is that we can see that every y-intercept is always in the form of 0, y. Or in other words, the x value is always 0. Now what's really important to note, if we look at this example, the x and the y-intercept can be the same point. Oops. So they don't have to be unique. They could be different. There could be one, there could be none of them. Like if I draw this graph here, this graph right here has no y-intercepts. So just like the x-intercept doesn't have to have one. So we know what and where the x and the y intercepts are on a graph. So this is how we'd find them just like with an equation. So we just use what we already know. And since we know that the x-intercept always has a y value of 0, that's what we use. So to find any x-intercept given any single equation, the first thing you're going to do is we're going to plug in y equals 0 because it's always 0, and then solve for the x value. Same thing if we're going to find the y-intercept. We know that the y-intercept always has an x value of 0. So the easiest way then to find the y-intercept would be plug in x equals 0 and then solve for y. So let's just practice that really quickly. The directions here are asking us to find the x and the y-intercept for both equations. So to find the x-intercept, we're going to plug in y equals 0. So if y was equal to 0, 3x minus 6, Let's add 6 to both sides, so we get 6 is equal to 3x, so therefore 2 was our x value. So to list the x-intercept, we know the x value is 2, and then we know by definition the y value is 0, so I'm going to plug in the y value of 0. So that is our x-intercept. Let's find the y-intercept for the same one. Now to find the y-intercept, we're going to let x equal 0. Just going to give myself a little more room here. So if we set x equal to 0, we have y equals 3 times 0 minus 6, so y equals negative 6. And we know it's a point, right? The y value is negative 6, and we only got that if we plugged in the x value of 0. So we go back and write down that the x value was 0. So just a few more examples. The one in the middle here is the equation y minus 4 equals 4 times x minus 6. We don't know what that equation looks like, but we can still find the x-intercept. Again, to find the x-intercept, we're going to let y equal 0. So 0 minus 4 should equal 4 times x minus 6. So we just solve, we'll distribute, so 4x minus 24, so we'll add 24 to both sides, so 20 was equal to 4x. So 5 was our x value. So the point, the x value was 5, and we know we only get that when we use the y value of 0. To find the x-intercept, again, we just let, I'm going to give myself some more room. We just let the the x value equal 0. So we're finding the y int. So x is equal to 0. So y minus 4 should equal 4 times 0 minus 6. So y minus 4 should equal 4 times negative 6. And then just adding 4 to both sides, we get y is equal to negative 20. So our y-intercept is 0, negative 20. The last example is, again, maybe a form that we're starting to see as standard form. So if we were going to find the x-intercept, we would let y equal 0. So if we let y equal 0, this would just be nothing. So we get 3x is equal to 12, so therefore x is equal to 4. So as a point, the x value is 4, and again, we only got that if we substituted y was 0. So the y value was 0. On to the x-intercept. For the y-intercept. So for the y-intercept, we know that the x value is 0. So we plug in 0 for x this time. And then we solve for y. So that's just 0. So we have 4y is equal to 12. So y is equal to 3. So as a point, 0.